he was saying this rain is nothing compared to. And story about a guy I worked with in West Texas. He was from one of the Carolinas and one of the resort cities. His parents were managers of a resort hotel, and they were right on the beach. Prime location, beautiful location, and the only problem was it rained half the time. And he hated it. So we went from that locale to West Texas working on oil wells where it almost never rained. And to quote him, he says, "I'm the saddest person around when it rains." He hates the rain. No, people of Zoom, can't see me. Hello, people of Zoom, sign your name in, please. I see most of y'all already done so. Can y'all hear me? Speak to me. If you can hear me. I guess you can't hear me. Okay. Here we go here with this. Okay. Can y'all hear me now? Can you hear me now? Okay.
Yeah, we can hear you.
Yeah. So you weren't hearing me before. Damn thing was set on the wrong setting. Okay, I'm getting the feeling we're gonna have a low attendance here on campus because of the rain. Which means I'm thinking I'm gonna have a larger presence on Zoom than normal. Oops, wrong one. Here we go. So instead of having 16 people on Zoom, I'm probably gonna have a few more. And the podiums in the classrooms up here are so new that they haven't had a chance to accumulate pins. So I have to use one pin. I teach in one classroom that has about 5 pins on the podium. And that's in Rose. They didn't update anything over there. Okay. Well, that way I don't worry about people accidentally walking off with my pen, which is okay because it's a school pen. For those of you on Zoom, you didn't get the benefit of your watching me drink my new favorite drink called C4. See, oh, I finally got the joke. Okay. C4 energy, kind of like the explosive. Okay, where am I? It's on. So, boom. Oh. All right. Oh, yeah. Somebody yesterday in one of my classes, whose last name is also Rodriguez, Mr. Mario, hit the P instead of the O. Made me laugh when they signed in. I don't know why. And Mario, I had you in last semester, right? If I remember correctly.
And I told you I have a very good friend who teaches at Harlandale, whose name is Mario Rodriguez. He goes by Pie Man online. Pie Man 314 or 134 Pie Man. I think his Instagram is 314 Pie Man. But he's funny. And he's actually a better high school teacher than I would have been, than I was. And he loves colored pens. He can't do anything unless he has about 6 or 7 different colored pens to do the work with. He's funny. But he's real happy now. He's a very proud papa because his daughter is a freshman up at UNT. And so they just had parents' weekend, and he went up there with his other 2 kids. And I think he's divorced. I don't think he's widowed. I think he's divorced. And my Facebook got flooded with his pictures of making stuff. Okay, did we do this problem? Did we do the sign one? This one? Did we do this one? Oh, so we did do this one?
Yeah.
Oh. I couldn't remember. So what we're gonna do now is, oh, that's right, we did do the word problem. Or one of them. The application problem, I should say. So now we're gonna go here. There's my Zoom, there's my Zoom. And there we go. Okay, now we're gonna talk about inverse, sine, cosine, and tangent. We don't talk about inverse, secant, cosecant, and cotangent. We only deal with the inverse functions of sine, cosine, and tangent. If you remember from college algebra, inverses, if you have a function f, and it's a 1-to-1 function, then you have a function f inverse, which they undo each other. So if you did a composition of f composed with f inverse of x, you get x back. So you wind up back in the place you started from. Right? You remember this notation from, and usually it was G. I found my fuzzy eraser. I had left it in a classroom that I don't teach out of thing anymore. I love my fuzzy eraser. Okay. G of x. I got this one. ATB. So G composed, F composed with G, or it doesn't matter which way you do it. F composed with G of x equals x. This is what happens with inverse functions. All right, and the notation for an inverse function is the exponent -1 on the f. So that's not f being raised to a -1. It's not the reciprocal, it's the inverse. And the inverse undoes what the function did. So the inverse of sine takes you from an angle to a number, to a real number. Well, the inverse sine takes that number and tells you what angle gave you that number. So that's what we're going to end up doing. Oh, and the composition F composed with G of X is the same thing as F of G of X. Which takes us back to X. So if I put 3 into the F function and find out what that is, put 3 into the G function and find out what that is, and then put that into the F function, I end up getting 3 back. So that's what happens with this functions. It takes you back to where you started. Or it undoes what the F function did. So we're going to find the inverse of sine function, find the value of an inverse sine function, define inverse cosine, find the value of inverse cosine, define inverse tangent, find value of inverse tangent, use the properties of inverse functions to exact values of certain composite functions. And a composite function is when you do a function on another function. So you're putting a function in place of X in another function. So that's what a composition is. And then we find the inverse function of trigonometric. All right. And solve equations solving inverse trig functions. Is there more? No. I think this is over 3 slides. Because I use a larger font for these. And so I combine them down to 1 page and used a smaller font, which I thought was a smarter thing to do. All right, so here's the sine function. Please notice from -1/2 pi to 1/2 pi, it covers all the y values for sine. And so this is the section we use. This is the section we use for the inverse. Because those are the reference angles for sine. So we're only looking at a restricted domain for the sine. Because all the values of sine will be those values. It just depends upon on what quadrant it's in. So definition of inverse is if y equals sine inverse, and that's how we say this, is sine inverse of x, if and only if x equals sine of y. Notice when you take the sine of y, you end up getting what you're taking the inverse of. And that's how the trig functions work. And so this definition, you can replace sine with cosine, you can replace sine with tangent. And it's going to be the same thing. The only thing that's different here will be your range and domain. For cosine, it's going to be from 0 to pi. And for tangent, it will be for cosine, inverse cosine, this will be from 0 to pi. And for tangent, this will be it'll be the same as this. Okay. So find the exact value of sine inverse -1. All right. Occasionally, I won't say sine inverse. I will use this word. I misspelled it too. Arc sine. Because this is how we used to say sine inverse, and then they started using sine inverse with the negative exponent. That's, I don't know why this switched, but they did. So what they're asking here is sine of what angle equals -1 between pi over 2, negative pi over 2, and positive pi over 2. So what angle in here equals -1? Keep doing this. Go back to the unit circle. The y value is -1. Right, so where is the y value -1 on the unit circle? Well, that's down here. And so that's going this way. So that's negative pi over 2. So this tells me that theta is negative pi over 2. So sine inverse of -1 is negative pi over 2. Questions? Let's see how they talk about it. Okay. So theta. So what this is saying is that sine of theta equals -1. And so for inside this interval, this closed interval is closed because it can equal the endpoints. And so when I say inside, in this case, we include the endpoints. Okay. And they just put up a chart of where between sine theta and sine of theta. Well, if you commit the unit circle to memory, or you can build the unit circle, this should be an easy thing to do, because we're looking at a restricted domain from negative pi over 2 to pi over 2. And, oh, nice graphic. Okay. So the only angle in that interval that equals sine equals -1 is negative pi over 2. All right. 3/2 pi also equals -1, but it is not inside that interval. So we can't use that one. There's a lot of angles that wind up here. But this is the reference, these are the reference angles for sine. Okay. So finding the exact values of sine inverse. Yeah. So it equaled -1, and that was from negative pi over 2. So 3 pi over 2. What angle theta gives us 3 pi over, the square root of 3 over 2. So I go back to my unit circle. Sine is positive, so that's up here. So which angle of sine gives me 3 pi, square root of 3 over 2? Well, isn't that isn't that this point here, which is 1/2 square root of 3 over 2? And isn't that angle 60 degrees or pi over 3? So sine in this case is pi over 3. So the sine inverse of the square root of 3 over 2 is pi over 3, or 60 degrees. But from this point, we almost always use the radian measure. There it is. Okay. So again, they set it up same way I did, except I kept in my head that it was between those two values. Simply by drawing the unit circle, and in drawing the unit circle, we're only dealing with half of it. Because that covers the positive and negative sign values.
I have a question.
Yes,
Is that domain and range always true for data?
for sign, yes.
So it'll always be negative pi over 2, and then between pi over 2.
Yes.
Okay.
For sine. For cosine, it's different. I think tangent is the same.
Okay.
So they got the same answer. Okay. All right, so when they say find the approximate value, then you use your calculator. On TI calculators, I don't know on other calculators, I don't know how they do that. But you will have the sine button, the cosine button, and the tangent button. And above it, you will have sine inverse, cosine inverse, and tangent inverse. So you hit the, what is it, second button, and then the sine, and so that's put sine to the -1 on your screen. And then you type in 1/3, so that's 1 divided by 3. And you close the parentheses, it's very important you close the parentheses, especially if you're putting more stuff in here. And hit enter, and it will give you a decimal number in radians. Well, first of all, you need to make sure your calculator is in radian mode. Because in radian mode, those numbers will be between -1 and +1. In degree mode, those numbers will be between what is that? -90 degrees and +90 degrees. And then you just round it to the second decimal place. And same thing with a -1/4. You just type it into the calculator appropriately, and it will give you the decimal approximation. Because the angle is to be measured in radians, first set the mode of the calculator to radians. And whoa. Yesterday, in my afternoon class, what just happened about 4 times. Where the PowerPoint went, bye-bye. It's so damn annoying. So I have to scroll down and find the screen again. Where am I? Further down, further down, further down. Almost. Oh. Yes, further down. Just one chair. What were we doing? Oh, yeah. I don't know why it freaks out, but it does. Okay. And so rounded to 2 decimal places is 0.34. So this is the calculator mode. Oh, for letter P that showed it calculating it, we get this decimal. And so they wanted 2 decimal places. So it's 0.25. Negative 0.25 or negative 0.25. Technically, you're supposed to put a 0 before that decimal point. There are some math instructors who insist you put the 0 point. I am not one of them. All right. Now, inverse cosine. They didn't show this picture for, did they show this picture for sine?
Yeah.
Okay, I just kind of went over it. Inverse functions are symmetric across the line y equals x. So this point and this point, all you're doing is switching your x and y value. This point and this point. And when the two, where the two intersect is on y equals x. Now, notice that the range is from 0 to pi. So your y values are from 0 to pi. Because the range, the domain for cosine here is from 0 to pi. With inverses, your range and domains switch. Okay. So now this domain became this range, and this range became this domain. This range. The range went from. Okay, yeah, the domain now is from oh, the new range is from -1. The old domain range was from -1 to 0. I mean, -1 to 1, and so that means the old domain is, the new domain is from -1 to 1. So we do this the same way we do with sine, but now, again, we're only dealing with half the unit circle, and so it's just from here to here. We're dealing from 0 to pi. so now we're looking at what angle in here? What angle in here is the cosine of that angle equals 1/2? Well, now we're looking at the x values on that unit, on the unit circle. Okay, so we're looking at where cosine of 1/2, I mean, the cosine of theta gives us 1/2 in that domain. Well, they show us in two different ways. One way is with the table, and the other way is in the chart here. And 1/2 is right here, so that would be this, which is what angle? Well, pi/3. So theta is pi/3, which means, okay. All right, theirs is more accurate than mine, I guess. And then so the cosine inverse of 1/2 is pi/3. Yeah. So in the unit circle, you have more angles that equal 1/2, but the only ones we're concerned about is in from 0 to pi. When you're dealing with cosine, just like with sine, you're dealing with negative pi/2 to pi/2. Okay. And again, we're looking at what cosine, the cosine of what angle equals the square root of 3/2. Well, that's this angle now. Because the x value, the coordinates of this point is the square root of 3/2, 1/2. So the angle that gives us those coordinates is pi/6. So theta equals pi/6. So the cosine inverse of square root of 3/2 is pi/6. Wait a minute. Negative. Uh-oh, negative. Negative is over here. So that's not pi/6, that's 5 pi/6. Because we want the cosine, we want the x value to be negative. And so, yeah, 5 pi/6. Yeah, negative signs will mess you up. I'm an example of it. Nice graphic. Okay. The only angle in the interval whose cosine is negative square root of 3/2 is 5/6 pi. So the cosine inverse, or the inverse cosine of negative square root of 3/2 is 5 pi/6. All right, tangent. Notice for tangent, x can be any number, any real number. Because if you remember with the tangent function, the tangent function, it comes from negative infinity and goes to positive infinity. And now, since our domain and range is switched, the range for tangent is all real numbers. So now the domain of inverse tangent is all real numbers. And the restricted domain here for tangent is between pi over 2, negative pi over 2, and pi over 2. So that's the y values from negative pi over 2 to pi over 2. So the y values are going to be between these two values, but they'll never reach those two values. Because since tangent doesn't exist at negative pi over 2, then you can never get negative pi over 2 with inverse tangent. And now, like with sine, we're only dealing with half of the unit circle, and it's the first and fourth quadrants. So it's from negative pi over 2 to pi over 2. And this is 0 pi. And so what tangent gives us a positive 1? Right? What?
45 degrees?
Which is what meridians. You always want these in meridians.
Pi over 4?
Pi over 4. If you can't remember, then just multiply by this. And that means you're just going to divide the degrees by, and then convert that decimal to a fraction. Which I know the I know the graphing calculators can do it, I just don't know how. It's in the math menu, I think.
I think it's just math fraction.
Yeah. And so it has two functions there, where one where it turns a fraction to a decimal, and the other turns the decimal to a fraction. And if you have a repeating decimal, that fraction you get might be close. So, yeah. Because you have to round at the end. Okay. Anyway, enough about that. So the angle that gives me 1 for tangent is pi over 4. So inverse tangent of 1 is pi over 4. So over here, negative square root of 3 over 3. Well, since tangent is sine over cosine, so I want to look for the one that has the square root of 3 for cosine. Square root of 3 for cosine is down here. So that's square root of 3 over 2, 1/2, because 1/2 over square root of 3 over 2 equals the square root of 3 over 3, because these go away and it's just going to be 1 over the square root of 3, and rationalizing the denominator gets you that. So that angle is, oh, and it's negative. So that's down here. So square root of 3 over 2, negative 1/2. So that's negative there, and that'll be negative. So that, yeah, I missed the negative sign. So that's a negative pi over 6. So they go through their steps. They're stating theta equals tangent inverse of 1. In where theta is between those two values. And so the inverse of tangent inverse is tangent, so the tangent of theta will equal 1. So what angle theta gives us 1 in these two quadrants. And that angle, they say. Okay. Wait a second. They didn't solve this, did they? They didn't say that theta was pi over 6. I mean pi over 4. They went straight. Oh. Sometimes I hate this program. PowerPoint. And so this one gave us. Well, looking at this one. Looking at this chart. To get a positive one, it was pi over 4. And to get negative square root of 3 over 3, it's negative pi over 6. So the tangent of negative square root of 3 over 3 equals negative pi over 6. Now, an interesting thing is, or a useful tool, tangent of a negative theta equals the negative of the tangent of theta. So in this case, tangent of a negative pi over 4 is the same thing as the negative of the tangent of pi over 4. And it holds true for the inverse function. Tangent inverse of negative square root of 3 over 2 is going to equal the negative of the tangent inverse of square root of 3 over 3, not 2, over 3. So positive square root of 3 over 3 is pi over 6, but we want the negative of that. So understanding that tangent and sine, cosine, and tangent, whether they're even or odd, their inverses will be the same. So sine and tangent are odd and cosine's even. So sine inverse and tangent inverse, sine and tangent are odd, so their inverses are odd. Cosine is even, so its inverse is even. That means the cosine of a negative degree is the same as the cosine of the positive. But since for cosine, we're dealing with the first and second quadrant, we don't use that very often for cosine. But it comes in quite handy with tangent and sine. So F inverse equals sine inverse. Oh, okay. Yeah, so this is properties of the inverse functions. If you take the function, if you compose the function with its inverse, you get the argument back, the original argument. And if you compose the inverse function with its function, original function, then you get the original argument back. And I had discussed that when I first started talking, when we first started talking about inverse functions, inverse trig functions. This is straight out of the properties of inverse functions, or you did that in college algebra. All right, please notice that they're restricting the domains in both cases. Because it needs to match up with the appropriate domains in those two functions. Okay. So to find the exact value of each composite, well, that's easy. What does A equal? Letter A, what do you get? What do you get? What does letter A equal? Here I'm taking the inverse of the original function. I'm taking the inverse of the original function. So I go back to this slide. What is that telling us? What is the argument of sine in here? That's what it equals. What's the argument of inverse sine in here? That's what it equals. Well, so we're doing the exact same thing here. We're composing a function and its inverse. You get the argument. The argument is pi over 8, so this equals pi over 8. Same thing is true here. It's the exact same setup. You get 5 pi over 8. Okay, now, the only trick here with this one is 5 pi over 8 in this interval. Five pi over 8 is larger than pi over 2. Because 5/8 is more than a half. So that takes us into the second quadrant. Well, what's that reference angle? The reference angle brings you back into yeah, okay, so now we're gonna look at the second one. All right, so that inverse, the inverse of this sine is not 5 pi over 8, because 5 pi over 8 is not in that interval. Okay, so we find an angle theta that is in the interval where these two are equal. This is where I use the word phrase reference angle. Well, this is where it's actually happening. Okay, so 5 pi over 8 is right here. Well, the reference angle for it is this angle. So that'll take us to over here. So what is this angle? Well, I do pi minus 5 pi/8. Because I go pi and then I come back this far. So that's gonna be pi minus 5 pi/8, which is 3 pi/8, which is what this angle is. So this here equals 3 pi/8. Right, so there, yeah. Because it took us to the second quadrant. But what's the reference angle? That has the exact same sine value. Well, that's 3 pi/8. So that equals. So the reference angle of 5 pi/8 is 3 pi/8. And since 3 pi/8 is in the interval, then sine inverse of sine of 5 pi/8 equals the same thing as sine inverse of sine 3 pi/8, which is 3 pi/8. So they got meticulous here for a change and showed that these two give you the exact same sine value. But this angle is in the interval we need to deal with. And so it's the reference angle for 5 pi/8. So find the exact value of. So that's just punching it into the calculator. All right, -0.5 is in the interval from -1 to 1 for sine inverse. So you just do, so that's just going to be 0.05. -2.5 is not in this interval. So it is not defined. When you think about it, sine is between -1 and 1. So I can't take the sine of any angle that'll give me a -2.5. Because there's no angle that'll give us that for a sine value. So this is undefined. No solution. Now, cosine works the same. Cosine works the exact same. It's just now, instead of going from -pi/2 to pi/2, we go from 0 to pi. And this one is still -1 to 1. Cosine values are from -1 to 1. And the angles we're dealing with are from 0 to pi. This falls inside 0 to pi. So this is just pi/15. Yeah. Here's pi/6. So pi/15 is going to be down here somewhere. -0.4 is in the domain for cosine inverse. So this is just going to equal -0.4. The negative of 3/4 pi is not in the domain 0 to pi. It's not in that interval. But knowing that cosine is an even function, which means that the cosine of negative x equals the cosine of x. So the cosine of negative 3 pi over 4 is going to equal the cosine of 3 pi over 4, which is in this domain. So this will equal 3 pi over 4. All right, letter D, they gave you letter D to trick you. All right, to confuse you, if you're not confused enough already. Pi is the number, is approximately 3.14. Since we're dealing with cosine inverse, the x values have to be between -1 and 1. 3.14 is not in that interval for the inverse of cosine. So this one is undefined, or does not exist, or whatever phrase they choose to use. So I hit the wrong button. So this is just pi over 15 because it's in the interval. Okay. Negative 0.4 is in the interval, the appropriate interval. Because we're the intervals we're looking at is the inside function. So the inside function here is cosine. The inside function here is cosine inverse. So if we're dealing with the inside function being cosine, then the interval we're looking at is from 0 to pi. If we're looking at cosine inverse as the inside function, then the interval we're looking at is from -1 to 1. All right, and as discussed earlier, negative 3 pi over 4 is not in the interval. But because the cosine is even, cosine of a negative angle is the cosine of the positive of the same angle. And so this is in the interval. So that equals 3 pi over 4. D is for D, yeah. 3.14 is not in that interval, so it is not defined. They're saying not defined, I usually say undefined, or it does not exist. Technically, not defined is the proper way to say it, but saying it does not exist is also appropriate, but it's not technically not correct. But it gets its point across. Oh my fuzzy eraser. And just keep myself from using my fingers to erase. My fingers would stay clean. Because a fuzzy razor does a much better job than those nasty things. So the composite function is not defined. Tangent, please notice with tangent, when the inside function is tangent, we're dealing with the same interval as sine, negative pi over 2 to pi over 2, because it's an odd function. That's why we're using this half of this unit circle. And when tangent inverse is the inside function, then x can be any real number. So there's no restriction on x if we use on x if tangent inverse is the inside function. If tangent is the inside function, so you're taking tangent inverse of tangent, then you have a restricted domain. So find the inverse function. Oh. So -2 sine inverse of what? X equals, I mean, is that a minus sign? I can't see it. It is. -1 equals y. Right? F of x is what y is. How do you find inverse functions? Anybody remember? Including you people? Anybody remember how to find inverse functions? Well, this is an important skill to have in mathematics. The inverse function is I'm going to switch x and y. So I'm going to write this as a -2 sine inverse of y -1 equals x. And now I'm going to solve for y. And that will give me the inverse function. So the first thing I'm going to do is add 1 to both sides. Because I just want to get it down to where it says sine inverse. So now I have a -2 sine inverse of y equals x plus 1, because I added 1 to both sides. And now I just want sine inverse, so that means I'm going to have to divide by a -2. So I'm going to divide both sides by -2. So those go to 1. And this leaves me sine inverse of y equals x plus 1 over -2, which is the fraction the negative of x plus 1. Someday. Let me just erase that and rewrite it. X plus 1 divided by 2. Now, if I take the sine of both sides, I take the sine of sine inverse, and I take the sine of -x plus 1 over 2. I get a sine of sine inverse of y, because if I do the inverse function of sine inverse, that gives me the argument out. So that'll get rid of the sine inverse on this side and just leave me the y, which is what I want. So now I'm going to do sine of the -x plus 1 over 2. So y equals the sine of -x plus 1 divided by 2. There's my inverse function. Or I could bring that negative sign, since it's an odd function, I can bring this sign out and say it's the negative, bring the negative sign out and say it's the negative of sine of x plus 1 over 2, and either way is correct. So this is the inverse of f of x. Oh, the domain in range of f inverse? Well, that means this number here, and I'm gonna deal with this one, so let's forget that one over there. To find the domain, that means it has to be theta has to be between -pi/2 and pi/2, right? For sine, that's the domain we're looking at. So this fraction here has to be between those two numbers. Oh, those bastards. I'll give you a hard one to begin with. Okay, so I have a -pi/2 less than equal a x plus 1 divided by 2 less than equal to pi over 2. First thing I wanted, because I just want x in the middle. So the first thing I'm going to do is multiply everything by a negative sign, so this negative sign goes away. What happens to inequalities when you multiply by a negative number? They flip. So this becomes pi over 2 greater than or equal to x plus 1 over 2 greater than or equal to negative pi over 2. Now I'm going to flip this, so the negative is on the left and the positive is on the right. So negative pi over 2 is the smaller amount, so that's less than or equal to x plus 1 divided by 2 less than. Okay. Oh, wow. It'd be just like if I didn't write it with that negative sign. Okay. Now I multiply everything by 2 because I want to get rid of that 2 in the denominator. So this becomes a negative pi less than equal to x plus 1 less than equal to pi. Right? 2 times pi over 2 is negative pi. And 2 times pi over 2 is pi. And 2 times x plus 1 divided by 2 is x plus 1. And now we're going to subtract 1 from all parts, all 3 sides, I guess. This is sometimes referred to as a triangular inequality because you have 3 parts, 3 sides. Okay. So subtracting 1, so I get a negative pi minus 1 less than equal to x less than equal to pi minus 1. And so that's my domain. The range is still going to be from -1 to 1. The range in this case does not change. Okay. So let's see. So interchange the x and the y. Yeah, I wrote it equal to y. And so it'd be equal to x. Either way it works. And then add 1 to both sides and then divide both sides by 2. And then oh, I had this wrong here, didn't I? So, all right. So finding the domain and range is going to be different. Because the inverse is going to be sine inverse. So that means the domain has to be between -1 and +1. Not negative pi over 2 and pi over 2. And so, yeah, okay. So, and my mistake was just we needed to add the sine inverse because that's what we were getting. So in the original way I wrote it as sine inverse and it should have been just sine. Now to find the domain. All right. Find the range of f, use the fact that the domain of f inverse equals the range of f. Okay. So since the domain of f is from -1 to 1, then the domain has to be between -1 and 1. Okay. And so they're gonna go. Oh, and I had that sign that the 2 was negative and the 2 isn't negative. Why isn't the 2? How did I see that oh. Because I can't see the lower half of the equal sign. So I read it as negative sign, -2. Okay. So that makes it a lot easier. And so that means, so this isn't gonna be negative in here. So that means x plus 1 over 2 has to be between -1 and 2, including -1 and 2. And so you go through the same steps I did, except we're not changing any signs. So you multiply everything by 2, and you get -2 less than equal to x less than x plus 1 less than equal to 2, and then you subtract 1. And so now the domain is between -3 and 1 inclusive. So now our new domain is -3 to 1. Or the set of all x such that that is true. So they go ahead and wrote it in interval notation. Oh, they also wrote it this way. Okay. So they use both ways. So that's the domain. The range of f is the interval -3 to 1, and the domain of f inverse is the same thing. Did they ask for the range? The range of f inverse equals the domain of f. And so the range of f inverse is -π/2 to π/2. So we're done. Okay. Solve that equation. That's an equal sign. And okay. So we have 12 times sine inverse of x equals 3 pi. Write that down right. First thing we want to do is divide both sides by 12, because I just want to know sine inverse. So sine inverse of x equals 3 pi over 12, which equals pi over 4. So we want to look at what angle pi over 4 is what x is. Right? Because sine and sine inverses are inverses. So if I take the sine of this, I'll give you the argument of sine inverse. So what is the sine of pi over 4? What's the sine inverse of pi over 4? I mean, the sine of pi over 4. Square root of 2 over 2. So x is the square root of 2 over 2. So they want to isolate the sine inverse because that's isolating the x term. Okay. Isolating the x term for these types of functions, these types of equations, mean you're isolating the sine inverse So you can do the sign on both sides. Then you divide both sides by 12, simplify. And then you rewrite it as sine using the inverse property of sine and sine inverse. So sine of x equals pi over 4 if and only if x equals the sine of pi over 4. And so that x has to be square root of 2 over 2, like we had said before. So the solution set, technically on it, and if you do, when you do this on an exam, this is how you write your answer inside this inside braces to show that it's a solution set. But okay. So this is more with trig functions, inverse trig functions. Oh. Now we're dealing with the inverse secant, cosecant, and cotangent. Find the value of inverse. Find the value of the inverse functions and calculate exact value of composite functions involving inverse trig functions. And then write trigonometric expressions in, as an algebraic expression. Oh my. Oh. Okay. Yeah. This last bullet point is a little tricky. So they're pretty much defined the same way. Secant inverse undoes secant, cosecant inverse undoes cosecant, cotangent inverse undoes tangent. So yeah, you have those situations. It's the exact same situation. Please be aware that the domain of secant becomes the range of secant inverse, and the range of secant becomes the domain of secant inverse. So secant inverse, if what you're taking the secant inverse isn't greater than 1 or less than -1, then it doesn't exist. Okay, so it's not defined there. Same thing with cosecant. With cotangent, you use x can be any real number. Just like with cotangent, just like with tangent. The tangent inverse, you can use any real number. Because secant and cosine are inverse, are reciprocal functions. The range here is the same as the range on cosine inverse, because cosecant and sine are reciprocal functions. Then the range of cosecant inverse is the same as for sine inverse. And cotangent, well, cotangent shifted. So it's not going to have the same domain as tangent, because cotangent it deals from 0 to pi. So the range of cotangent, I mean the range of cotangent inverse is from 0 to pi. I can see those graphs in my head, which is starting for me. But anyway, So secant. This tells me I want to find out what angle of cosecant of secant gives me 1. And with secant inverse, I forgot. 0 to pi. Right, secant at 0 to pi, yeah. So 0 to pi, theta has to be in between 0, 0 and pi. So and since secant is 1 over cosine, so 1 over what number gives us 1? Well, 1 over 1, right? So where is cotangent 1 between 0 and pi? So this means the cosine, cosine of theta is going to equal 1 over 1 because they're reciprocals. 1 over 1 is 1. So where is cosine 1 between 0 and pi? Anybody?
Is it pi over 4?
What? Pi over what?
Pi over 4?
Nope. That's square root of 2 over 2. That's right here. This is pi over 4. What are your quadrantial? First thing to do is put in what your quadrantial angle are. That's 0, 1, that's 0, 1. I mean 1, 0, 0, 1, and -1, 0. The cosine is the x value. 1. This is the angle 0. 0 is in between 0. Well, 0 equals 0, so it's in that range. Or in that domain for secant. So that just equals 0. Secant of 0 is 1. Cosecant is dealing with sine. But so this is going to be the cosecant of theta equals 2. So that means that the sine of theta is going to equal 1/2. Knowing that the reciprocal functions really help with secant, cosecant, and cotangent. So what angle is the sine 1/2? All right, sine we're dealing with from -pi/2 to pi/2. Since it's going to be positive, that means it's going to be up here in the first quadrant.
Is it 30?
Hmm?
30?
30, which is what radians?
Pi over 6.
Pi/6. So cosecant inverse of 2 is pi over 6. Cotangent inverse, so writing this as cotangent, so cotangent of theta equals the negative square root of 3. Right? So that means the tangent of theta equals 1 over negative of 1 over the square root of 3, which is the negative square root of 3 over 3. We're dealing with the same angle degrees as sine, from negative pi to pi. Since tangent is negative, we're dealing with these angles down here, though. So the two angles we're looking at are either negative pi over 6 or negative 3 pi over 6. Because negative 3 pi over 6 is a negative 1/2, no, it's 1/2 negative square root of 3 over 2. I know I'm writing it too small for the people on Zoom. So we have 1/2 negative square root of 3 over 2. And that's for negative pi over 3. And for negative pi over 6, the point is the square root of 3 over 2, negative 1/2. So which one of these gives, because tangent is y over x. So which one of these y over x gives me, well, I know cotangent is x over y. That's gonna be the easier one to do. So which one putting x over y gives me a negative square root of 3? Because that same angle will give me a tangent of negative square root of 3 over 3. Well, because I need to get square root of 3, that means square root of 3 needs to be in the numerator. So square root of 3, negative square root of 3 over 2 divided by 1/2. These 2's go to 1. And so that's just going to be negative square root of 3. So it's this lucky boy. So it's a negative. Right? So negative 3 pi, negative pi over 3. Knowing the relationship between tangent and cotangent and x and y of the coordinate points on the unit circle. That's all I need to know. I don't need to memorize what tangent is for each angle. I just need to know what sine and cosine is for each angle. So I don't need to memorize an extra bit of numbers. But if you do it enough times, it starts residing in your head. That's the secret behind memorization, is to do it, say it, read it over and over again. All right, so let's go through their explanations. Didn't I tell you at the beginning of the class that free calculus will make you look at numbers in a totally different way? Because you have to. All right, so secant inverse, then theta is an angle between 0 and pi, where is not equal to pi over 2, because at 90 degrees at pi over 2, secant is undefined, because you're dividing by 0. So the secant equals 1, or equivalently, whose cosine equals 1. Well, the only place where cosine is 1 is at 0. And so this, where secant is, cosine is 1, secant is 1. And we get that it's 0. And now the second one was almost as easy. And again, cosecant, we say that the angle can't be 0 because with cosecant, the function does not exist at 0. So 0 is out of the running in that scenario. So we want to find the cosecant that equals 1, which means the sine equals 1/2. Right, because sine and cosecant are reciprocal functions. And so the reciprocal of 1/2, the reciprocal of 2 is 1/2. And the angle for sine that gives us a positive 1/2 is pi over 6. So it's pi over 6. So I don't know cosecants. I know sine and I can find cosecants. I don't know secants. I know cosine, so I can find sine, cosecant. So I can find secants. Same thing with tangent and cotangent. It's just a reciprocal. Okay. This one, from my point of view, was a little trickier. Simply because you need to determine which ordered pair gave you the x over y to give you a negative square root of 3. Okay. So the only theta in that, the only angle in that domain that gives us a negative square root of 3 for cotangent is 5 pi over 6. Isn't that what, is that what I got? I don't remember what I wrote down. What I write down.
You turned it into a tangent.
Yeah, I turned it into tangent. And then, but then I started looking at well, and I was looking at the wrong coordinates as well. I was looking at the right domain. Because that's this part. And so we're looking at and I think I didn't deal with the negative sign. So we get 5 pi over 6. All right, so So since the calculators don't have the secant and cosecant and cotangent, so then you need to determine cosine or cosine inverse. So do cosine inverse of this and then do the reciprocal.
For that, couldn't you do 1/cosine to get secant on the calculator?
But we're doing this, so it would be 1 divided by cosine inverse of 8. That makes sense? Cosine equals 1/8, so you find out what, so you do. Yeah. So cosine inverse of 1/8 is approximately 1.45. I see what they're talking about here, yeah. So they did the cosine of the inverse of the argument. So they did the inverse of 8, so they did the cosecant of 1/8, which is a more, this may not be the right answer. Where this is. There may not be that direct relationship between the inverses. Okay. And with cosecant, okay, again, we're going to deal with sine now. So sine is sine of 1/2. Except where it's undefined. And so we want to find the sine of what theta gives us -1/2. So we're going to do the sine inverse of -1/2, which gives us a -0.25. I'm -0.52. And we're just about at time. And so we'll finish this one out. And so again, we're going to use the fact that cotangent and tangent are inverses. So this is going to be the tangent okay. Why cosine? Is this a typo? Okay, I hope it's a typo. No. And where do they get 1/√26? Oh, they really screwed up with this one, didn't they? They really screwed up with this one. No, that is not right. That is so not right. We would do the same thing as we've been doing before. So cotangent theta is going to equal 1/5. So that's tangent of theta is going to equal 5. So the tangent inverse of theta, the tangent inverse of 5 equals theta. Boy, I messed up big time here, didn't I?
But that's where it's custom.
Yeah, that's past time. We'll start here next time.
Does the sign up sheet was ready?
Yeah, please be sure you sign up, and if you're online, please be sure you signed in. I hate it when they mess up like that.